Imagine walking into a massive, world-class restaurant, sitting down and just saying to the waiter, "Food, please." I mean, you might get a perfectly cooked steak, or you might end up with a bowl of plain white rice. It's a complete gamble, right? Well, honestly, that is exactly what most people do when they first start using generative AI. Welcome, everyone. Today, we are going to fix that. Our goal in this explainer is to transition you from a casual AI user to an advanced prompt engineer. We're going to start treating natural language not just as a casual chat, but as actual code. So let's dive right in and learn how to truly command these powerful systems.
You know, the phrase pre-train, prompt, and predict perfectly captures this massive paradigm shift we're seeing in computer science. In traditional software engineering, you'd write super precise code in languages like Python or C++. But today, natural language itself has essentially become the new programming language. And what's incredibly powerful about this is that you don't need expensive GPU compute or complex fine-tuning to steer generative AI. You literally just need the right words.
Because of this, prompt engineering isn't just typing questions into a box. It is a rigorous discipline and absolutely the core skill of the AI era. There's that old computer science adage, garbage in, garbage out. If you give an AI a vague, messy instruction, you are going to get a vague, messy, and probably hallucinated output. But when you transform your natural language into highly structured instructions, you fundamentally shape the model's behavior. For enterprises right now, this is rapidly becoming a make or break capability.
Here's a quick look at our roadmap for today. 1. What is prompt engineering? 2. System versus user architecture. 3. Advanced prompt design patterns. 4. Safeguarding against prompt injections. 5. Expanding context and modalities. And 6. Automated and programmatic prompting.
Okay, starting off with Section 1, what exactly is prompt engineering? Let's totally demystify this right from the start. A perfect prompt is a highly structured interface, and the best way to build one is using what we call the 4-block mega-prompt pattern. You absolutely need 4 things: a role, the context, the task, and the output format. Let's look at a clear before and after. A generic user might just write an email about our new AI feature. That's our food please order from earlier. It's garbage in. Now let's use the framework. Role, act as a senior software salesperson. Context, the customer signed up for a free trial yesterday. Task, write a follow-up email explaining our new automated AI feature. Format, output this as a short 3-paragraph email with a bulleted list of benefits. Night and day, right? That highly detailed structure will consistently outperform unstructured prose every single time.
Moving right along to Section 2, System versus User Architecture.
When we step up from a basic web browser chat and start building real enterprise applications, prompts get split into 2 very distinct categories. Think of the system prompt as the application's operating manual. It's completely stable. It holds the persona, the strict behavioral rules, and the style guide. It doesn't matter if you're on turn 1 or turn 50 of a conversation, it stays the same. The user prompt, on the other hand, holds all your dynamic runtime variables, the specific question a user just asked, or maybe a document the system just pulled up. A really huge mistake people make is mixing these up. If you start stuffing dynamic, changing content into the system prompt, you break the system's caching and totally confuse the model's attention. Keep the stable manual and the dynamic task completely separate.
All right, Section 3, Advanced Prompt Design Patterns. So, once we have that basic architecture down, how do we actually make the AI smarter? This is where we dive into cognitive mechanics. The best prompt engineers treat prompts like levers on a machine. You have to know exactly when to pull which one. If you just need simple data extraction, a standard direct prompt is totally fine. But if you're dealing with a complex logic problem, you need to use chain of thought. Need real-time data? You've got to deploy React patterns with tool definitions. The takeaway here is that there is no one-size-fits-all magic prompt. It's all about matching the specific cognitive technique to your specific scenario.
Let's look a bit closer at chain of thought, because it's fascinating. In a standard prompt, you ask a question and the model basically blurts out an answer. If the underlying logic is complex, it's highly likely to make a mistake. But with chain of thought, we intentionally force the model to generate its reasoning steps sequentially before it gives us the final answer. Literally, just by adding a phrase like, "let's think step by step," you force the model to show its work. This massively mitigates one-off reasoning errors and can give you up to a 40% gain in accuracy for complex tasks. 40% just from asking it to think out loud.
And here's an incredibly practical tip for you when you're iterating with AI. Use this self-refined workflow. You really don't have to settle for the first draft. In this framework, you instruct the model to generate its output, but then you have it critically evaluate its own output for any errors or missed constraints.
Finally, you have it rewrite the response based entirely on its own feedback. It's this built-in self-correction loop. It requires absolutely zero extra model training, but it dramatically improves your final result. The golden rule here is always iterate.
Let's jump to Section 4, Safeguarding Against Prompt Injections. As our prompts get more complex and we start letting AI access external tools and data, we absolutely must establish strict architectural guardrails. Which brings us to the million-dollar security question. How do we stop rogue inputs? We're facing two main threats here. First, you have direct jailbreaks. That's when a malicious user actively tries to trick the AI into ignoring its system prompt. But second, and honestly much more dangerously, we have indirect prompt injections. This happens when your trusted AI reads an untrusted third-party email or a web page that actually contains hidden text commanding the AI to do something malicious. So how on earth do we stop this?
Industry leaders like Anthropic highly recommend a few key mitigation strategies, all based on the principle of least privilege. For starters, you can use super-fast, lightweight models to screen user inputs for malicious intent before they even touch your main AI. You also have to explicitly tell the AI in your system prompt that external data is untrusted and should never override its core instructions. Also, using JSON encoding is huge. It provides completely unambiguous boundaries, so the model knows exactly what is a direct command from you and what is just a block of external data it's processing. Bottom line, treat all external data with extreme skepticism.
Section 5. Expanding Context and Modalities. Now, we've talked a lot about text so far, but the very nature of the prompt is going through a massive evolution right now. Multimodal prompting is a total game changer. Let's say you wanted an AI to analyze a software interface. Previously, you'd have to sit there and manually describe every single button and text box in your prompt. Not only does that burn through tokens, but it introduces massive human error. You're probably going to miss a crucial detail. Now, you simply attach the raw visual or audio context directly to the prompt. Instead of trying to describe the world to the model, you just let the model see the world for itself. The accuracy you get from this is absolutely wild.
And finally, Section 6, Automated and Programmatic Prompting.
Welcome to the absolute cutting-edge frontier of prompt engineering. We are rapidly moving away from humans sitting at keyboards typing out paragraphs of text and straight into automatic prompt optimization, or APO. In this methodology, we literally use one AI to write and test prompts for another AI. It generates the instructions, scores how well they work against your training data, and mutates them to be better. And here's the craziest insight from this research. The absolute best, most highly optimized prompts often contain bizarre, totally unnatural phrasings that a human being would never naturally come up with. It turns out, machines are just better at speaking to other machines.
In practice, frameworks like Stanford's DSPy are completely changing how we work. You don't write text templates anymore. Instead, you define your input and output signatures programmatically. From there, a compiler algorithm runs experiments, collects data, and automatically mutates the instructions to find the absolute most optimal mathematical path to the right answer. We're literally replacing human heuristic guessing with compiled, auto-optimized foundation pipelines. It is incredible.
As researchers Holtzman and Tan point out, prompting is not a workaround, it is behavioral science. Because we can't easily peek inside the black box of a neural network and its billions of parameters, prompting is the primary scientific tool we have to actually understand these complex new organisms. It isn't just some temporary hack or modern alchemy. It is a rigorous, empirical method we use to probe the very limits of machine intelligence.
Which leaves us with this final, rather provocative thought. We started today with a basic restaurant order, moved our way up to 4-block mega prompts, and ended up at algorithmic machine compilers. As AI models become better and better at generating and optimizing their own instructions, will the human art of writing prompts vanish entirely? Or will we just evolve into architects who manage the compilers? It is a massive evolutionary leap. If you found this explainer helpful and you want to keep mastering the AI tools of tomorrow, make sure to hit that subscribe button. Keep experimenting, keep iterating, and until next time, keep learning.